Hello and welcome to the final Black Belt session of the day. This is the secret session on CNAB, Cloud Native Application Bundle. We have 3 speakers for this secret session. We have Gareth from Docker. He's a product manager at Docker and contributes heavily to the Kubernetes project. And we have Matt, who is a principal engineer at Microsoft. He is one of the creators of the CNAB project. He's heavily involved with Kube. He also heads the Helm project, which is part of the CNCF Foundation. And we have Radu, who is also an engineer at Microsoft in the Azure division. And he's involved with the Kube project again and contributes to CNAB. So you can get started.
Okay. So thanks for coming to the last session today. As you know, this is the secret session. This is a bit of a DockerCon tradition. There's often something on the schedule. It's a secret. You don't know what's going to happen. Hopefully, we'll make it worth your while for coming along. So yeah, I'm Gareth Rushgrove. I'm a product manager at Docker for developer tooling, predominantly. So Docker Desktop and some of the things you saw in the keynote. So for a little while, we've been working on Docker App. It's a way of really sort of simply packaging up a compose-based application, sharing it on Docker Hub, and sort of parameterizing it for people to use. It works everywhere outside keynote stages, it turns out. So we'll hopefully show some demos of it working again here. What we didn't say in the keynote today, because actually it's just been made public about 25 minutes ago, is actually in Docker App, it implements a new specification for bundling distributed applications together. As we were working on Docker App, we ended up with a whole bunch of interesting conversations with other people building similar tooling or customers with similar problems. We sort of hit on that it's a bit more of a general problem than maybe we thought, but also that led to conversations with people like Matt from Microsoft on how do we work together to solve that more general problem. So I'll hand over to Matt, who's going to talk you through what the heck is Cloud Native Application Bundles, or CNAB for short.
Yeah, and we've been working at a breakneck pace for the last couple of months in order to get this here. And we're really excited because part of my team's philosophy is that when you release open source, you just want to get it to the point where it's usable, and then you open it up and you hope that the community can rally around it. So I'm really excited because this is the first talk where we'll talk about the development tools. You will hear more about this tomorrow at the keynote, but this one is going to be far more developer oriented. We're going to talk a little bit about some of the underlying details and our longer term vision for it. And then we're going to swing back and do a couple of demos. First Gareth doing some, and then Radu doing some. So, and when we got started with this, it was a rather lofty idea. And we were very nervous about trying something like this because it felt impossible. But we tried a little bit, and then it seemed slightly less impossible. We worked on it some more, and then we were going, wait, there might be something here. And we kept working, and so we are really excited because it felt so big and scary when we started, and now we feel like we've made really good progress on an idea that we think is going to solve a major problem. So here's where I'd like to start. For so long, we've all been telling each other distributed applications are the future. Distributed applications are the future. Cloud came along, and cloud was the first real technology that made it possible that we could build very large infrastructures in a very distributed way. And anymore, it's not the case that distributed applications are the future. For most of us in this room, distributed applications are the present. But what's happened is we've focused a lot on the distributed part. We built large tool suites, but we have not focused very much on talking about a distributed application as an application, right? One particular thing. So what our theory is that if we can start talking about a distributed application as an application, this will lead us to useful conversations and useful tools. And the first one that we think is going to be very useful is to talk about this using the package management metaphor. Say, imagine if we can wrap our arms around a distributed application and say, all these pieces here, this is my application. Those other things out there, no. And then we can create reproducible builds that we can move around easily from dev to stage to prod, or put up in marketplaces and be able to package things up and move them. The cloud is here, obviously, but the shape of it is different than we thought it was going to be. And it's different than the hype that we told ourselves before, because we created a very, very broad ecosystem. And this is something that's a little bit embarrassing, but also a little bit awesome, right? You go to your public cloud service provider, and you click on that menu to see all the services there, and you are instantly overwhelmed by the fact that there are hundreds of these. I've seen many cases where two application developers are developing approximately the same kind of application, and based on which things in here they pick and choose, the underlying shape of the application is very different, even though the user experience is often fairly similar. Do you know what I mean here? We pick different databases, we pick different kinds of caches, we pick different underlying VM versus container technologies. What that indicates to me is that developers themselves are not terribly comfortable with the huge wealth of available things. And yet one of our expectations is we'll pick and choose some of these services, we'll become experts in them, and then when we hand this off to our users or our ops teams or whomever, we will expect them to be experts in this same suite of technologies that we are. So let's flip it over and talk about applications. When you click through an installer, when you do brew install something or other, when you do apt-get install, right? We don't even ask the question, what's the underlying technology? Was this written in C? Was this written in Python? We just expect the installation routines to take care of all of this for us. So what is it that makes that experience fundamentally different from the experience that we're sort of perpetrating in cloud world right now, right? Well, when we think with the kind of lens of an application, then we're thinking, okay, an application is something that can be packaged. So I have to think about my application as that kind of thing. And then it can be distributed. It can be installed multiple times in multiple locations, some of which I'm not aware of right now as the developer today. That, by the way, is one of the things that drives me crazy about cloud services, is that we often tend to develop it here and then realize after the fact, oh, I can't run it over here without spending a whole bunch of time configuring this environment to look identically to this one. It can be configured, upgraded, uninstalled, monitored, interrogated, but it can also be made available as an app in a marketplace. Or it can be delivered offline. So think of it this way. We don't currently have a terribly good story for how to take a cloud application that's running in my public cloud, download it to a USB stick, walk across an air-gapped network and plug it in and hit install and have it reconstitute in the other environment. But we could. And we think that we figured out a way to do it. And then finally, we want to start with the assumption that these things need to be secure. So we want some cryptographic verification and attestation built in from the get-go. You can see what I mean when I say when we sat down and started enumerating this problem, we're going, this is impossible. There's no way to do this. But we've been kind of chipping away at it a bit at a time. And we've come up with CNAB. Cloud Native Application Bundles. It's a cloud-agnostic packaging format that's designed to kind of wrap its arms around this distributed application and be able to do reproducible builds and installs and upgrades. So let's talk about the different pieces of a CNAB bundle, okay? So a CNAB bundle has two essential components. It's got what we call a bundle descriptor. This is the part of the bundle that says, hey, this particular bundle does this, it's named this, its version is this, right? The basic metadata. And then here are the different configuration things that you can do with it. Then the second part is called the invocation image. And an invocation image is what you wrap up all the actual logic to run the installation, the upgrade, the uninstall. And then finally, and we'll just touch on this because this is very much work in progress, we need an idea of where we can store these things and how we can come back and retrieve them later, and how we can share them. So here we're going to go a little bit into the technical details of it, and we're going to talk about the bundle descriptor, which we called the bundle.json until we realized that as soon as we cryptographically sign it, it's actually not JSON because of the hash around the signature on it. But the bundle file looks something like this. Okay, you've got a fairly readable, I hope, manifest here that says, here's the name of the application, here's the version number, here's the description, here are the invocation images that we use, the things that can actually do the installer. And then here are the Docker images or other kinds of images that compose this application. And then down at the very bottom, you can see a couple of empty sections where we've got parameters and credentials. Let's stay on that slide and talk about that. So parameters are the kinds of things we want to be able to configure. We're all used to how parameters work when we use regular installers. You click on something, you get a little text box, you have to fill it out. Credentialing was an interesting problem. When you're using like apt-get or homebrew or something like that, the security model when it comes to identifying you as the user is fairly straightforward. The person running the program is the user that's executing the program. And I as the operating system, merely check whether that user has permissions to install stuff in the location it's asking. When we're talking about a kind of bundle that can install into a Docker Compose for some stuff running on a local host, or in other cases, Azure with ARM, or AWS, or Google Cloud, none of those systems have that same kind of built-in contract where they can just say, oh, I know who you are. We have to provide credentials. So this posed one of our first kind of challenges, because you don't want your bundle to have the credentials baked in. You don't want them to be in your images, and you don't want them to be sticking around after you've run the install. So we broke those two out so that we could handle credentialing and configuration separately. So as you just saw on that last slide, you can sign these kind of bundle manifests. And because we can calculate what the hashes are of your images and populate all of that into the JSON file, then when we sign it, we have kind of a worthy record of exactly which pieces we need to be able to pull down in order to reconstitute this application. And then when we present an installer, and we'll come back to this a little bit later, we can show, hey, we recognize this bundle was signed by someone that's known and in your keychain. Okay, so that's the bundle.json file. Let's talk about the invocation image. This is the installer piece, the part that actually contains the logic to to set everything up, right? So an invocation image is an OCI image, a Docker image, that contains the necessary workflow for installing an application. So imagine that you want to install stuff into Kubernetes using Helm and also contact some of the Azure APIs and also maybe contact something like Cloudflare, right? So you've got 3 different sets of APIs, 3 different sets of tooling. You don't want your user to be exposed to having to install all 3 sets of tooling, right? But the bundle can have them because it's a Docker image and we can compose it to be whatever shape we want it to be. So we can load all those tools in there, wrap around it whatever we need to expose the parameters and the credentials. And then when the user executes the install action, the container itself has all the tooling readily available, already configured to know what to do with it. When we got started, we sat down and talked about some of the personas. Who is it that we're targeting? And when it came to describing the user, that was fairly straightforward. When it came to describing developers, it got a little bit harder. Because we weren't sure what patterns would emerge. We're still not totally sure. But what we did realize was that most of the time, and again, Docker is a perfect example of taking this mentality seriously. Most of the time, developers would prefer not to have to dive all the way into the bowels of a technology in order to build something very quickly, right? You can write a Docker file without understanding even the layering system initially, right? And that's one of the beauties of it. It's why I got started with Docker in like 5 or 10 minutes instead of a couple of weeks. So whatever technologies we build around CNAB, we want to make sure we tool toward that particular case. However, there's this like small segment that needs the expertise and needs it to apply it in very specific situations, right? Highly security conscious organizations may need to actually dive deeply into the technology to understand what the implications are for their security frameworks. People who are building brand new suites of tools that would come with their own, alternative to something like Ansible or Terraform, they need to be able to have something where they can hook deeply into this system. And so as we've tried to spec this whole thing out, we've tried to keep in mind that the base case should be fairly straightforward, while the expert case should be possible. So here's what a CNAB bundles file system looks like. So again, an invocation image is a Docker container. And so inside of it, we have a file system. And again, we want to make sure that when you're building these bundles, you can install the tooling necessary to do the things you need to do. If you are using Terraform, we want to make sure you can install a Terraform client into the CNAB bundle to be able to stand it up. If you're using Helm, same thing, right? So here's a very simple example that just installs the Helm Alpine chart. So that you can see there's a CNAB directory, and there's inside of the CNAB directory, there's an app directory. That's the part where we get prescriptive. We say, okay, the directory CNAB, not a commonly used directory name. We're going to reserve that directory. So inside of your Docker images, this is where you put your CNAB stuff. And then the rest of the file system can largely look how it needs to look. So what goes inside of one of these? Well, really there are three things. The first one is what we call a run tool. This is basically the entry point that the Docker container, when the container runtime will call to execute this, right? And this tool is responsible for taking verbs like install and kicking off a task workflow that will actually perform the installation. So there's a series of pre-configured or required verbs, install, upgrade, delete, but then it's an extensible system where we can provide other verbs should we need them. Second category of stuff we need is supporting files. If I'm installing Ansible, I need the playbooks. If I'm installing using Terraform, I need the TF files. Again, Helm, Kubernetes, they each come with their own kinds of files. So we want to make sure that all those supporting files can be placed in here. And then finally, we have tried to define a specification that would allow you to also put a lot of the metadata in there. It would be awfully nice to be able to inspect an image and see the Docker file inside of the image that said how it was built. Or to take a look at the build time configuration that the developers were using. And so in the specification, we included a location for all of that. The verbs that are required to be supported in order to be a CNAB compliant runtime: install, upgrade, uninstall. I hope that the text there was highly redundant as to what they're expected to do. But the idea is the verb is sent into the bundle. The invocation image receives the verb and says, okay, given this and the parameters the user supplied and the credentials the user supplied, it is now my job to go run these tasks and perform a complete installation and let the user know, yes, it successfully installed, or no, it did not. Okay, here we're going to go in a little bit of an interesting direction. In order to solve that air gap problem, where I take my application from one place, walk it into something like a SCIF or an air-gapped network or an IoT-constrained environment, we need to be able to provide the images. Because when we walk it across the room, that's how we do it. But it's kind of burdensome to provide all of those images if the goal is to merely install it from one region in cloud to another, or one tenancy to another. So we have two different formats in which you can package these bundles. The thin format provides just the metadata along with the references of where you can pull the images. The full bundle is actually a full binary that contains that invocation, the invocation image, the bundle.json, the bundle descriptor, and all the images necessary to actually run this application. So you can easily imagine that these things could get into the gigs as far as file size go, probably beyond if you have really big applications. But what it does is, by being able to package these things, export them, walk over, plug them in, and import them, you can move the images around and consequently make it possible to achieve some of these stories that, again, when we started out on this, we thought, I don't know if we're going to be able to do this. Okay, the last piece that we're just going to kind of throw out there what the basic ideas are, but we have no concrete implementation yet, is this bundle repository. And so this is the place where you can store the bundles, find the bundles, share bundles with each other. And what we want to do is we want to add that to the standard and make sure that we have a standard way of doing all of that. We're in the fairly early investigative stages with using Docker registries to be able to do this, and we're pretty excited about it. So I've just introduced a whole bunch of ideas and said they're part of a standard. And many of you are going, well, okay, you can throw together a standard and kick it out there all the time, but first of all, why? And second of all, can you actually, or is there actually any tooling? Well, to answer the first question, we want to release it as a standard because we have some very specific concrete use cases in mind, but we know that our concrete use cases are not going to represent the broad set of needs out there. But if we can agree on a standard for a packaging format, we can work together as a community and create all the diverse set of tools we need to be able to accomplish everything from setting up stores and marketplaces on one end to solving internal ops problems, in complicated air-gapped networks. So that's why we created it as a standard. CNAB gives us a kind of cloud-agnostic technology. It's designed to be able to work on any of the public clouds, on private clouds, on OpenStack, and it's built as an open standard with open tooling, and it provides us with a clear way of describing what a distributed application is as an application, but without being bound to specific vendors' infrastructure and workflows. But just importantly, we've tried really hard to not overreach. So if you happen to take a look at the standard, which is at cnab.io, what you will see is we've defined the parts that we feel are very necessary in order to make this work. But we've tried not to get hyper-opinionated about what everything ought to look like. And that's in order for the standard itself to mature, for a diverse set of tooling to emerge, and so on. So our end goal really is to create something like RPM or Debian or MSI or Homebrew for the cloud. And if we can focus on building portable and reusable applications that can easily be distributed, we're actually causing a very big change. Because when you think about the way most of us work on the cloud today, we make several assumptions. The people who are working on it are domain experts in multiple technologies. The applications that are written for it are largely still, right now, bespoke applications, right? Custom applications that were tooled specifically for this platform. A trend that I'm very happy to see changing, but one that as of today is still very much true. And we're assuming that we will have full ops teams to do this. So if we can successfully do this, we've signaled a change from the cloud being a place for that kind of application into the cloud as a runtime, as simply a runtime. Whether we're using sophisticated applications or very straightforward applications, the user need not know how we accomplished all the stuff we accomplished. They only need to know whether they can install it and whether it will run. All right, so we'll get onto some demos here, but quickly, Duffel is a reference implementation that my team has been working on, and you've already been introduced to Docker App, which is another reference implementation that Docker has been working on. Duffel is designed to be a reference implementation. So when you see it, it is a command line tool that is designed to show you how CNAB is designed to work. Docker App takes the approach that it is a developer-first tool that provides the developer with a great user experience and happens to use CNAB under the hood. We cannot be more excited about the fact that these two things are co-evolving because it proves out both the spec and the user story, the DevX story that we want to be able to tell. So Duffel is a package manager implementation, supports all the different pieces that are out in the spec, and we are working right now on that last bullet point, which is starting to support CNAB repositories. For my team, in addition to providing Duffel, we're also working on Visual Studio Code extensions. We're working on a graphical installer. We're working on trying to figure out ways to do declarative versus imperative kinds of bundles. And again, I've said this multiple times now, we're working on a reference implementation of the repository. So at this point, I want to hand it back over to Gareth, who's going to do some demos, and then over again to Radu. You're good.
Is that big enough at the back? Thank you. And that's the context to CNAB. And I'd say Docker app that you saw a bot demo of earlier just uses that under the hood. Rather than you having to, like that bundle file contains all the information to be compatible with CNAB, so we can build a bundle that could be used by any other CNAB client or system or stored in a CNAB compatible repository. But how's that actually working? So again, I've got a little example application here. It's a little bit different to the one we showed earlier. Actually, in this case, it's just one file. So Docker app supports either just a single file or multiple files for sort of slightly more complicated applications. What this is doing is sort of not super relevant to this talk. It's really just a very much hello world. It's launching a little web server that echoes back some text you put it. So fingers crossed. I think it's going to work. Come on. Hey. So that's what should have happened on the keynote stage. And again, that's it. We've used compose file. We could have set a number of different. If we have a look at the application, you can see the parameters we had that we could have overridden. So we could have changed the default port. We could have changed the default text. But I'm not really talking about the Docker app part of that. Please do check out some of the talks that are going on and have a look at the Docker/app repo. What I am talking about is, well, what's that to CNAB? So actually, Docker app can automatically under the hood basically build this as a CNAB bundle. So when I run that command, it's created the invocation image that Matt mentioned. That invocation image contains the tooling. It contains the tools required to run that compose file. It has a run script that basically takes in the credentials required to run that. And also, if we have a look now, we've created a bundle.json file. So, to Matt's observation, like this is the specific stuff that's specified in the CNAB spec. This is lots of information. This isn't necessarily designed for you to write by hand. You, of course, can do, if you're on that sort of 10% curve, you can go and write this by hand. You can create your invocation images by hand. You can take any toolchain you want and have it implement that very simple interface of install, uninstall, upgrade. With Docker app, for a specific use case, well, we just generate all of that for you. And you can see this is relatively verbose because this is intended for the tooling, not for the end user. For Docker app users, this is just an implementation detail. And obviously, you could have, over time, different CNAB clients that take a different stance on how much of this you expose, either purely as an implementation detail, or do you expose some of it at a higher level. In here, you can actually see that, well, we know it's a compose file. We're being opinionated about the type of application here. And well, that can be run on Kubernetes or it can be run on Docker. So we've automatically generated a number of parameters to get the credentials in there. You didn't have to tell us what they were because we already have some opinions. We've expanded the sort of simple high-level syntax for parameters in the Docker app into the sort of more verbose but also more powerful specification for bundles. So and with the reference input, like with that file created, if you were to take the Duffel reference implementation that I think we're going to see some demos of shortly, you could install this with that as well as doing what I just did with Docker app. The other side of that, so that's the sort of, well, I can use Docker app to create a CNAB compliant bundle that could be used anywhere else you're using CNAB tooling. The other side of that is Docker app is a CNAB client as well. So it can be used to install CNAB bundles that maybe came from elsewhere. So Matt had some of this example in there earlier. There's this is actually let's have a look inside charts. So this bundle, again, just has a CNAB folder. In there, actually, we have a Helm chart. But we have a bundle.json that sort of is describing it as making it a CNAB bundle. And we should be able to do docker app install. Here I provide basically a context. This is a CNAB construct whereby I've created a set of credentials. We sort of abstracted that away when it came to the Docker app one because we're opinionated about certain things. The bundle here is much more generic. And we should be able to point at that. And so what's happened there is we've actually installed a Helm chart on our Kubernetes cluster with where my credentials came from the local part. So that's my Kubernetes cluster running on Docker Desktop. And we've done that via the CNAB bundle. So we've got one user interface at the top level here with Docker app with a simple way of installing. I've shown a compose-based application. I've shown a Helm-based application. If we'd had more time, we could dig into applications which were maybe provisioning things on Azure with ARM templates. Much more interestingly, and I think Matt's often talked about WordPress as the sort of hello world of the cloud. You can imagine a CNAB bundle that used Azure ARM templates or Terraform to stand up an Azure database, like a custom client that sets up some DNS, and like Kubernetes configurations or Helm charts or compose files to stand up the actual WordPress services on your cluster. All of those things can be packaged in one go and installed through the same user interface or any CNAB compatible client. So with that, I will hand over to Radu for some demos of some of the other things that we've been working on. Oh, you'll want to... No, I'll just... Yeah. I'll double check it works on this.
Hello, everyone. So first of all, Matt mentioned the website for the specification, cnab.io. And this should be the first place you want to go when you want to read about cloud-native application bundles. After you do that, you can go to GitHub and start looking at the specification. That's open sourced as well. And here, if you go on that, you can have an understanding about what is a bundle, the invocation image, the bundle descriptor. After you have an understanding of that, there's the reference implementation that we've been working on, Duffel. And this is what I'll be showing shortly. And after that, we've been working on a bunch of example bundles for some popular applications. And essentially, these are examples on how to get started and how to build the bundle yourself. So essentially, how you get started with Duffel is you go to GitHub, you get the binary for Duffel for your system. And at that point, you should have Duffel in your path, right? And we try to make it as simple as Duffel create and give it a name. And essentially, this will bootstrap a development environment that should contain, first of all, the exact directory structure that we've seen so far. So a CNAB directory, which contains a run script, a run executable. And then there's also a build manifest. That's the place where you would put things such as the maintainers, the keywords of your bundle. And then the most important thing, where is your invocation image? What's the directory of your invocation image? Configurations such as registry, things like how do I build the image? And as well, what images do I want inside my bundle? And one of the things that haven't been shown so far are, so if we take Gareth's example earlier with Helm, I want to install, I had a Helm chart which uses an image. Essentially, if I want to change the image that Helm chart is installing, what do I do normally? I do set, I do find and replace the image, I do all sorts of things, right? If I have the bundle descriptor, the images field is set specifically for that, right? So whenever I have the image Alpine, the path in the bundle where that image is used is in CNAB app charts in the values file. And if I want to change that, I simply change the path, either the path where the file is used, where the image is used, or the image itself. So I said that getting started is just duffel create. At this point, I want to build the bundle, and I do a duffel build, right? What this will do is it will do a Docker build on the invocation image. It will take my CNAB directory and all my invocation images locally, and it will essentially follow the instructions on how to build the image. In this case, I'm using a Docker file to build it. Essentially, any OCI compatible image can be used for that. And this is how my invocation image is used. This is bootstrapped by duffel create for you, together with the folder structure. And at this point, because I have a folder called DockerCon, I can do a duffel bundle list. And I should see a bundle called DockerCon version 0.1.0.1, right? So at this point, I can do a duffel install. And if I can spell. And at this point, this will use the Docker, the duffel binary. It will use whatever driver I have compatible and installed locally. In this case, it will use the Docker driver to run the invocation image. And it will start executing the run script. In my case, it's a fairly simple run script. It's just a bash script that essentially takes a look at if I want to do install or if I want to do uninstall. And essentially, inside the case statement, I can have all my tools that I want to use. So if in my case I want to have a Helm install, that's what I would use my Helm binary. This can be as easy to write as a bash script or as complicated as any programming language binary outputted as you want, right? So for you to get started, CNAB.io. This is the CNAB spec and the duffel reference implementations. And if you have any questions, there's a mic up front.
Yeah. The end of the day, people are coming up.
Hi, great talk. Looking forward to this a lot. I have a question for Matt. How does this relate to Helm exactly?
I have no idea. No. I'll be really honest. When we finished writing Helm 2, that was the first time when we realized the major thing that we couldn't do with Helm 2 was manage images. Helm 2, all the versions of Helm, right? Manage Kubernetes manifest files, and we're hoping that it manages them very well. But we never devised a way to manage the Docker images. And that bothered us. And we tried a couple different things, and that's what really started to get us down this particular path, where we said, oh, so we should add something in here that can deal with the images. But as soon as we started that conversation, we went from the Kubernetes layer and bumped ourselves up to a more general cloud layer, and then became aware of all the other issues, such as that today's distributed application doesn't necessarily use only Kubernetes. There's a whole bunch that don't use Kubernetes at all, and we hope to we hope to change that as the head of the Helm project. We hope to change that, but we also want to facilitate the different people's workflows and the different styles they did. This supports Swarm. This supports Microsoft Service Fabric, all the IaaS platforms, and the realization initially was hard to deal with because we had to admit the shortcoming of Helm. And then it was hard to deal with because it felt like an insurmountable task. But again, as we started going through this and understanding what tools look like, how tools can be used, and how maybe perhaps the solution was a fairly lightweight specification that just defined the runtime layer, all of a sudden the pieces started to fall together. So to us, this is a tool that's complementary to Helm because you can embed Helm inside of a CNAB bundle and execute it. It actually gets rid of some of the problems because you can be very specific about what version of Helm you need to use for this particular version of a chart and this particular version of Kubernetes. And so we of course are continuing our work on Helm 3 and our other projects that are Kubernetes related while working on CNAB and Duffel and this kind of level up of cloud aware tools.
Yeah, thank you.
I'll add one thing to that as well. Based on the work we've done with Docker App, and right now Docker App is very opinionated about it starts with a compose file, although you can run that on Swarm or Kubernetes. I think what we'll see over time, hopefully, is you'll have tools which have this sort of one-to-one mapping between the description, the tool chain you're using, whether it's Compose, whether it's Helm, and actually give you a CNAB bundle. So there's no reason why there couldn't be, I don't think we've talked about this, but there's no reason why there couldn't be a Helm plugin that actually has a very simple, and even Helm bundle creates actually you a CNAB compatible bundle of the Helm chart. It's just files on disk. So moving those around or creating the bundle.json that's what we're doing with Docker App. I think we'll also see tools which you can then better compose different tool chains together. And then there's the full-on experts. You can literally do anything by building an invocation image and writing that bundle spec data by hand. So.
Thanks for your talk. Have you considered a use case like analogous to multi-architecture binaries? Maybe I can have a package that will use one provider's load balancer if that's the environment I'm installing into, or another provider's load balancer, something like that.
You want to answer already, or you want me to? Okay. Yes, we have considered it, and we are not entirely sure about some of the details. And again, part of our rationale for releasing this when we do is because we know that people who are already concerned about these things will bring more domain expertise than some of us who say might really only run our stuff on Azure. But I will tell you where we've gotten so far. You would notice that in all the slides you've seen of the bundle.json file, invocation images is an array. But we keep talking about how there's an invocation image. Now, the idea is that, first of all, we have to solve the architectural problem, where there may be multiple Docker invocation images, each designed to handle the nuances of different architectures. ARM, well, the easy one is a Linux versus a Windows kind of invocation image runtime. And so we made that an array, but our intention was that the tooling would select the best one for the environment, and essentially they would all be functionally equivalent, though the technology inside of a particular container might be different. That was a problem we felt like we could solve and solve it safely. But then there's the second problem that you brought up. Say you want to build a bundle that contains all the requisite logic to install on AWS and on Azure. And say, let's throw in Google Cloud as well, right? I'm not the person who can build those bundles for you. So I can't recommend that that's a particular good architecture. But there are experts out there who feel totally comfortable working in all three of those cloud environments. And the way the parameters and the credentialing was set up, you should be able to toggle back and forth if you so desire. Yeah. But for the kind of short term, we're suggesting that that probably it's best to do one bundle per target cloud, whatever target cloud means. However, we're also more than willing to listen to the experiences that early adopters have that can give us feedback about whether it's tenable and whether it works well for them and how much expertise a bundle developer ends up having to shoulder in order to do that kind of thing.
One of the things you'll see, I think, when you play around with this is the spec is very general. So if you can write a script I like in your favorite programmable language of choice, that ultimately has a case statement and that takes a variable that says AWS or Azure or GKE or pick your poison and does a different thing, you can build an invocation image yourself that takes that code, puts it in the image, has the different configs for those, and exposes a parameter and that toggles between them and the credentials that would do it. So the spec is very general. That's very powerful. And over time, I guess things like that could become more first class. I would sort of say actually, it's best to see what happens in the space of the invocation images. I think we'll see all sorts of actually pretty terrible things. And we'll see, like, because hard things are possible, like that. Easy things should be easier, and I think that's where higher level tools come in. Like, if everyone ends up writing these bundle.json files by hand, we've weighted too much towards that 10%. But you can do this today if you actually where the bits are buried.
Yeah, and it essentially boils down to whether you want to have as much configuration parameters and credentials into a single bundle, as well as tooling in an invocation image, or have a higher level tool that selects the best bundle based on your parameters.
Worth calling out, there are actually a load of example bundles that have been created, and some of the ones I've been showing today, the Hello Helm one. There's loads of other ones in here. Now, I think this is and some people are going to be, oh, cool, I can geek out about the spec. Other people are going to be like, oh, I'll try out Duffel. I think people to start with, a great entry point is actually build an invocation image. Where we have good examples, like I can submit PRs upon here. There's already 5, and it only opened a few minutes ago. I'm sure there were none before. But yeah, I am sure someone will create a multi-cloud one and get it on here. Again, like discovering the best practices around this will take the community as a whole time. Okay. So any last questions? I think we're good.
Yeah, thank you guys very much.
Thank you. Again, we'll have more bits in the keynote, so feel free to be on the inside track now until then, when people ask you what the secret session was about. But no, thank you for coming.